The following question is about esters, and the question states that there are two esters and they have the same molecular formula C3H6 and O2. So two esters having exactly the same molecular formula, they're going to have 3 carbons, 6 hydrogens and 2 oxygens. And he's asking what are the names of these two esters. So you're given 4 options: methyl ethanoate, and ethyl propanoate, ethyl methanoate, or propyl methanoate. So what I'm going to do is I need to draw each ester first. So remember that esters have this particular functional group. So I'm going to start with the first one. So the first one is methyl ethanoate. Esters have this functional group, C double bond O. All esters are going to have this functional group, and there would be groups attached on either end. Remember, this first ester is methyl. Methyl means meth stands for 1 carbon atom. Methyl is going to be this side. The alkyl side is going to be this side. So there's going to be 1 carbon atom on this alkyl or side which has a suffix YL. And the other side would be the ethanoate side. Ethanoate, eth stands for 2 carbon atoms. So meth stood for 1 carbon atom, whereas eth stood for 2 carbon atoms. So over here on this side of the functional group, I'm going to write 2 carbon atoms. One is already there, so that means I just need to add 1 more carbon atom. And now to complete the bonds, I would have to draw hydrogen atoms. This carbon atom would need 3 hydrogen atoms. This carbon over here would also need 3 hydrogen atoms. So if you now count the total number of carbon for this molecules, there's 1, 2, and 3 carbon atoms. So that's C3. The total number of hydrogens for this are 1, 2, 3, 4, 5, and 6. So there are 6 hydrogens, and there are a total of 2 oxygens. So that's O2. So this first option is correct. It will have a molecular formula of C3H6O2. Now moving to the second one. The second is ethyl propanoate. So let's start with the functional group again. Let's start with C double bond O, and O, this is the functional group. And this side is your alkyl side, the YL side. So this side has its ethyl. That means eth means there are going to be 2 carbon atoms. So on this side there are going to be 2 carbon atoms, whereas on the other side that's propanoate. Prop stands for 3 carbon atoms. So you're going to have 3 carbon. 1 is already there. So there's the second one, and there's the third one. Now I don't need to actually continue on, because even if you look at this partial structure, there's 1, 2, 3, 4, and 5 carbon atoms. So the formula cannot actually be C3H6O2. So this one is definitely incorrect. Now moving to the next one is ethyl methanoate. So drawing the structure of ethyl methanoate, I'm going to let's draw the structure on the same. Redo this part. So I'm going to this is the ester group. Now this one is ethyl. So that means on this side there are going to be 2 carbon atoms. Eth stands for 2 carbon atoms, and on the other side you have methanoate, which stands for 1 carbon atom. So on the left hand side, on the C double bond O side of this functional group, there's only 1 carbon atom. So this is going to be the structure, and we're going to complete all the other bonds. There has to be another hydrogen so that carbon has 4 bonds. This carbon is going to have 2 more bonds. This one is going to have 3 more bonds with hydrogen. So now each carbon atom is making 4 bonds. Now if you look at the structure, there are 3 carbon atoms, so that's C3. There are 1, 2, 3, 4, 5, and 6 hydrogen atoms. That's also correct. And there are 2 oxygen atoms. So this is also correct. So this one is also correct. So 1 and 3 are going to be the correct options, and that would give you option B. We don't need to actually check 4, but let's, for the sake of for completing the question, let's check 4 as well. If you look at 4, it's propyl methanoate. So I'm going to start with the C double bond O ester functional group. Propyl means that there are 3 carbon atoms. On this side, 1, 2, 3 carbon atoms on the single bond O side. Methanoate means there's only 1 carbon atom. So there's only 1 carbon atom on this side, and that's 1 carbon atom. Let's complete all the other bonds. Each carbon atom should be making a total of 4 bonds. So I'm adding hydrogens everywhere. And this one is also incorrect, because if you simply count the carbons, that's 1, 2, 3, and 4 carbon atoms, whereas our molecular formula just had 3 carbon atoms. So this Fourth option is also incorrect. So the second and the fourth options were incorrect, whereas 1 and 3 were correct. So option B is the correct answer for this question.